All right, we're on a series. The topic is binary number. We want to solve binary number problem. For example, they say evaluate this value in base 2 multiplied by this value. So what do? The first step you need to do is identify. If you check very well, this particular one is multiplying this one, or this one is multiplying this one, whichever way you want to use, but always use the smaller one to multiply the bigger one. All right, so what I mean is that bring these values out. 1 1 1 0 1 1. This is in base 2 multiplied by 1 1. Both of them are in base 2. So when I got my final answer, I'll place this in base 2. We just know that both of them are already in base 2. Then you bring your multiplication sign. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. 1 times 1 is 1. 1 times 1 is 1. Now you take this, or use this other value now to multiply everything again. But before you start from where this one start from, under it. Like, what I mean is I use 1 times 1, we give you 1. 1 times 1, we give you 1. 1 times 0, we give you 0. 1 times 1, we give you 1. 1 times 1, we give you 1. 1 times 1, we give you 1. So at this point, you have to add. After you have used this value to multiply this, you have to what? You have to add. Now, in binary numbers, you know, since it is in base 2, you know that when 1 is added to 1, it gives you what? It gives you 10. Now, you can prove that by writing it in a prime factor method. For example, since it is in base 2, right? If I add these 2, it will give me 2, right? If I add this 2, it will give me 2. So, for example, if I have 2 goes to 2, it will give me 1, remainder what? 0, right? 2 goes to 1, it will give me 0, remainder 1. When you take it up, you see that you have 10. So, that is why it is stated that 1 plus 1 is 10. All right? But if I have, for example, I will have, whereby I will have 1 plus 1 plus 1. 3 of the 1 gives you 11. How do you do it? If I bring 3 in base 2 as a prime factor, how many times can this go? It can go once, remainder 1. It can go once. It can go once, remainder 1. It can go once, remainder what? 1. You see that you have 11. So it's a proof. I will come back to this when I'm solving it. Now, 1, you bring that 1. 1 plus 0 is 1. 1 plus 1, I told you is 10, right? I've already done it there. You take down 0, carry 1. This 1 plus this 1 gives you 10. You take down 0, carry 1. This 1 plus 1 is 10, plus 0 is 10. You take down 0, carry 1. Now, 1 plus 1 plus 1 is 11. Now, most people don't understand how that 1 plus 1 plus 1, how come it becomes 11? It was a question I was asking before, and I know so many of you are asking the same question. Now, look at this. On the normal norms in mathematics, 1 plus 1 plus 1 is 3, right? Since 1 plus 1 plus 1 is 3, now it is in base 2. So I bring my 3, then I now use base 2 format, that is prime factor format. I have 11. That is how that 11 comes about. So I will write 1, carry 1. 1 plus 1 plus 1 will still give me 11. I carry 1, right? 1 plus 1 will give me 10. So this is in base 2, and this will be my final answer. So whenever you are being given a binary in a binary expression that in the same base that you should multiply, this is the format you are going to use to solve your problem. So this is where we end the video. Thank you very much.